These are recovery notes for Chapter 2 for the grade recovery. So let's start with problem number 1. It says find the slope of each line. This first line is a vertical line, and so the vertical line should have a slope that is undefined, and just to prove that, I will work the problem so we have a difference of the y's. So let's just pick two coordinates here. This coordinate here is a 1, 2, 3, 4, 0. This point is 1, 2, 3, 4, 1, 2, 3, 4 negative. So this point is 4, negative 4. And so if we find the slope, it's a difference of the y's. That would be a minus 4 minus 0, minus 4 minus 0 over the x's, which is 4 minus 4. That'd be a minus 4 over 0, and anything that's a division by 0 is undefined. So that's the slope of that line. So before we get in too deep here, let's just reiterate. Anything that is a vertical line is going to have a 0 as a denominator for slope, and that slope will be undefined. Anything that is a horizontal line is going to have a slope of 0, because 0 will be a numerator, and I'll work that in just a second. And so to take it one step further, the equation of this line would be x is equal to 4. So an x equal type line is a vertical line, and vertical lines have undefined slope. This would be the line y equals a negative 1. That's the equation of the line. And finding the slope is going to be the point negative 1, 2, 3, negative 1, and 1, 2, 3, positive negative 1. So let's find the slope. The slope would be the difference of the y's, a negative 1 minus a negative 1 all over a negative 3 minus 3. So that would be equal to a negative 1 plus 1 all over a negative 6, 0 all over negative 6. So this one has a 0 in the numerator. A 0 in the numerator just gives you a slope of 0. So remember, a 0 in the numerator is 0. A 0 in the denominator is undefined. Okay, the next one. So we'll go from one point to the other. It doesn't matter which direction we go. So if I'm going from the first point to the second point, I'm going over 1, 2, 3, then 1, 2, 3, 4 down. Actually, I should go in the reverse order. I should have gone down first. So let's try that again. We go down first, then over 3. That would be one way to do it. So the slope is going to be the rise. So the rise of this would be going down. That would be a negative 4. And then we'd go right. 1, 2, 3 would be 3. So my slope is equal to a negative 4/3. Now, if we instead went from this point to the point over here, we could go the other direction. We could go up 4. 1, 2, 3, 4. So the slope would be a positive 4. But then we would go to the left 3, and that would be a negative 3. So again, my slope would be a negative 4/3. Okay, so let's go over to the next one. Slope is up 1, 2, 3. Then I go over 1, 2, 3, 4, 5, 6. So my slope is 3, 6 is equal to 1/2. Here's a line, x equal to 4. Remember, that's a vertical line. Vertical lines have the slope that's undefined. It's x equals. The slope of this equation, this is in slope-intercept form, y equals mx plus b, where this is the slope, so the slope is equal to 2/5. Here's an equation that is in standard form, so to find the slope, let's put it in slope-intercept form. So we want to get it into the form y equals mx plus b. So my first step would be to subtract 7 from both sides, the 7x from both sides. So I have a minus 4y is equal to a minus 7x minus 20. Now divide both sides by 4, a negative 4. And let's be careful here. This is going to be, of course, a y. Now on the other side, I have a negative 7x all over negative 4. Let's go ahead and just write that out so we don't lose any signs. And then I have a negative over a negative. That would be plus 20 over 4. So what I'll have is y. Now I have a negative divided by a negative, so that's going to be 7 over 4x. And put the x up by the numerator because it is a numerator. Don't put it down here close to the 4 because it's not a denominator. And plus 20 divided by 4 is 5. Okay, find the slope through each pair of points. I'm going to do this in 2 ways on one of these, and then I'm just going to do it one way on the others. I'm going to first use the method by using the point slope formula. So the point slope formula is y minus y1 is equal to the slope x minus x1. So the first thing I have to do is find the slope of this line. I just needed to make sure it was still running. Something strange happened there. Okay, so the slope of this line would be 13 minus 9 all over a negative 11 minus 6. That would be 13 minus 9 is 4. A negative 11 minus 6 is a negative 17. So the slope of this line is a negative 4/17. So let's go ahead and put those values in here. Now the y1 and x1 are any point that I choose. So this x value here, x1, I think I'll pick as 9, and the y1 value, the x1 value I'll pick as 6. The y1 will be 9. So let's go ahead. Y minus y1 is equal to the slope times x minus the x1 coordinate. So let's work it on out. I'm going to get y minus 9 is equal to, and my slope was a negative 4/17. A negative 4/17 x, a negative times a negative, is going to be a positive number. So 4 times 6 is 24. Now what I'll have to do is add 9 to both sides. So y minus 9 is equal to a negative 4 all over 17x plus 24/17 plus 9, and I'm going to make 9 into actually, I just realized this thing just asked for the slope. It didn't ask for the equation of a line, so I went way overboard on this. That's what I was checking there. So actually, the slope of this line, I got that at the start, was negative 4/17. So the rest of this was not needed. So I found that right here. Okay, let's find the slope of the next one. So the slope is equal to the y-coordinate difference, which is 4 minus 4, all over 8 minus a negative 3. That is 0 all over 8 plus 3, 11. So the slope of this line is equal to 0. Next one says sketch the graph of each line or inequality. For this one, I'm going to use standard form. Now you could put this in slope-intercept form if you wanted to graph it, so I'll just write the equation in slope-intercept quickly, but I'm going to graph it in standard. So if I wanted to put this in slope-intercept form, I would subtract x from both sides. So I would have 5y is equal to a negative x plus 5, and then I would divide by 5, and I would get y is equal to a negative 1/5 x, and of course the x is a numerator, plus 1. And then I could plot it that way. But what I'm going to do is I'm going to first say, okay, we're going to find out where the intercepts are. That means I would set one of these values equal to 0 and see what the other variable equaled. So if, for example, to find the x-intercept, I would set this y equal to 0. So that would be 5 times 0 is 0, and you can kind of cover this up. And all I would have is x equal to 5. So I'd come over here, because the y point is 0, and I'd put my intercept at 5. Now I need to find the other one. So what I'm going to do is I'm going to set the x-coordinate equal to 0. So if I set the x-coordinate equal to 0, this would go away, and I have 5y equal to 5, y equal to 1. So there's my intercept. And now I'll simply draw the line. And looking at what I would have gotten if I would use slope-intercept, it's the same thing. Look, my y-intercept is 1, there it is, and the slope is a negative 1/5. Down 1 and 5 to the right. 1, 2, 3, 4, 5. Okay, this next one over here is x is greater than or equal to 2. That's going to be an inequality. And what I'm going to do is I'm going to put the line x equal to 2 on here. And it's going to be a solid line because of the equal to sign. So here's the line x equal to 2. And then I'm looking for all values of x that is greater than 2. So that would be values to the right where x goes up, so that part will be shaded. Okay, here I'm graphing a line in slope-intercept form, and it's an inequality. So let's go ahead. My y-intercept is b, so b is equal to 4 right there, and the slope is a negative 1. So up here at 4, where it crosses the y-axis, the slope is a negative 1. That would be down 1 over 1. This is an inequality, so I'm going to dash the line since there's not an equal to sign. Now I'm going to test a point. Since 0, 0 is open, I'm going to test that. That's the easiest one to test. So putting 0, 0 in, so I got 0 is less than a negative 0 plus 4. 0 is less than 4. That's true. So the point 0, 0 would be shaded. Okay, the next one is y is greater than or equal to a negative 4. So let's draw the line y equal to 4 on there. And it's going to be a solid line because of the equal to part. So y is equal to a negative 4. Solid line. And I'm looking for all values where y is greater than a negative 4, though, which would be all the values going up. Find the slope-intercept form of the equation of the line. Okay, well, let's try to use y equals mx plus b if we can. And we need to find the y-intercept, b. Well, there it is, right there. So b is a negative 1. And let's find the slope. Here's another point I can use. So it is for the slope, it's rise over run. That would be up 2. And then I go over 1, 2, 3. So my equation would be y is equal to 2/3, and put the x up there by the numerator, 2/3 x, and my y-intercept was a minus 1. There's the equation of my line. Find the slope-intercept form. Well, this is a horizontal line, so it's just going to be at the point where the y values are constant. This is the line y equals a negative 2. This is the line x is equal to a negative 4. X is a vertical line. This is a line that is passing through the point 0, 0 is my y-intercept. It has a slope, so b is equal to 0. The slope is down, let's go to this point here, down 1, that'd be a negative 1. To the right 2, it's a negative 1/2. Y is equal to a negative 1/2 x plus 0. So we would write that simply as y is equal to a negative 1/2 x. Okay, we're writing the equation of the line. Okay, so this is the one where I could use point slope or slope intercept. So let's go ahead and just find the slope of this line. M is equal to a negative 4 minus a negative 4 all over a negative 2 minus 0. That would be equal to a negative 4 plus 4 all over negative 2. That's 0 all over negative 2. So my slope is equal to 0. Well, 0 slope was a horizontal line. So this is a horizontal line. And that's going to be a y equals line. And what are the values of y in this? They should be the same. And it would be y is equal to a negative 4. Okay, moving to the next one. Okay, I'm going to try to write this line then in the two methods. So let's go ahead and find the slope. M is equal to 5 minus 1, 5 minus 1, all over 1 minus 4. 5 minus 1 is 4. 1 minus 4 is a negative 3. So the slope is equal to a negative 4/3. Okay, so now using the point slope method, I would have y minus y1 is equal to the slope x minus x1, where x1 and y1 are some point. I'm just going to use the first point. So I have y minus y1, that's 1, is equal to the slope, that's a negative 4/3, times x minus 4. So I have y minus 1 is equal to a negative 4/3 x. A negative 4/3 times a negative 4 is 16/3. And now I'm going to move my y over by adding 1 to both sides. So y is equal to a negative 4/3 x. And if I add 1, I'm going to put it in the form of a common denominator. So that would be plus 16/3. Adding 1 then is the form of 3/3. So I have y is equal to a negative 4/3 x plus 19/3. Using point slope intercept form, I could do it by y is equal to mx plus b. And now I'm going to need to find b. So what I'll do is I'll put in the point, one of the points that I know. So I'm just going to use the same point. 1 is equal to, now the slope is a negative 4/3. And the x point would be 4 plus b. So 1 is equal to a negative 4/3 times 4. That would be a negative 16/3 plus b. Now let's add 16/3 to both sides, so that would be 1. And I'm going to change the form of 1 to 3/3 plus the 16/3 I'm moving over. And that would be equal to b. So you can see that b is equal to 19/3. So now substituting the b into this equation and the m into the equation, I get y is equal to the slope, a negative 4/3, x, and b is 19/3. So those are the two ways to find it. Okay, now we're going to find the slope, the equation of a line through a negative 4, negative 3, parallel to this a line. So what I'm going to do is I'm going to use the slope of the line I'm parallel to. If I'm parallel, I'll have the same slope. So the slope of my line is going to be equal to 1/2. So let's just go ahead. Most of you like to use the slope-intercept form, so I'm going to say y is equal to mx plus b, and I'm going to substitute in my slope and a point. So my point is a -3, m is 1/2, x is a -4, plus b, -3 is equal to -4 times 1/2 would be a -2, plus b. Now I'm going to add 2 to both sides, so I have a -1 is equal to b. So now substituting those values in, I have y is equal to the slope times x plus b. Okay, now I'm going to do one over here, and it says that I am passing through -1, 4 perpendicular to the line y equals 5. The slope of y equal to 5, that's a horizontal line, and that line has a slope of 0. So my line would have the negative reciprocal of this slope. So basically I have a horizontal line and I'm perpendicular to that. So my line is actually it's an x equal line, and it would have a slope of undefined. So this is not one we're going to be able to work out in equation form. I can look at what I have here, and I know that my line has an undefined slope because it's perpendicular to a horizontal line. So my line has to be the type that says x equals. Okay, so what it's going to do is if I look at the point -1, 4, it's going to have to equal the x coordinate. So my line is simply x is a -1. Okay, here's another one that says perpendicular, and my line is going to have the negative reciprocal slope of the line that's listed. So what I have here is the slope of the line that I'm given is 11/2. So my line has to have the slope of a -2/11. It's the negative reciprocal. Actually, that's not what this thing is asking me to do. Sorry, it was just on a roll there. I need to put this equation in standard form. So what I need to do that is I need to get rid of my denominators first. So what we see is that I have a denominator of 2 and I have a denominator of 1 on this side. Okay, so I have y is equal to 11/2 x minus 6 over 1. And so my common denominator is 2. Now I'm going to multiply the whole equation by 2, as that's going to get rid of my denominators, because standard form has to be the form where I have ax plus by equal to c, where there are no denominators. A and b are integers, and the a is positive. So a, b, and c, they have to be equal to integer. They have to be integers, means no fractions, and a is positive. Okay, so I have to get rid of all the denominators. So multiplying by 2 will do that. Taking a 2 times y, I get 2y equal to 2 multiplied over here would be 2 times 11. So the 2's cancel out, giving me 11x. And finally, the 2 would also multiply by a -6, giving me a -12. So there I have eliminated my denominators. And now then I need to get so that the x and y are on the same side. So I'm simply going to minus 11x from both sides. And what that's going to give me is a -11x plus 2y is equal to a -12. And now I need to have the x be a positive number, so I'm going to divide everything by a -1. So if I divide this side by a -1 and this side by a -1, all my signs change. So what I would have is 11x minus 2y is equal to 12. And there my equation is in standard form.